Hello and welcome to a new video on cryptography for everybody. As you probably know, I have not uploaded many videos recently, and that was because I was really busy. And one point why I was busy was the CrypTool Symposium. The CrypTool Symposium was in Munich. And on that symposium, all CrypTool team members, so members from CrypTool 2, Java CrypTool, CrypTool 1, Mystery Twister, and so on, gathered together to discuss the current developments and the future of CrypTool. And of course, I also gave a talk about CrypTool 2. And today, I want to repeat this talk on my YouTube channel, and I want to give you an overview of the newest components and the most interesting components of the last 3 years. As you can see, the talk was named Status of CrypTool 2. I had that talk on the 31st March 2023 in Munich. I structured my talk into 4 different parts. In the first part, I introduce what is CrypTool 2. Then, in the second and biggest part, I'll show you new highlights from the last 3 years of CrypTool 2 development. After that, I will show you a few examples how we use CrypTool 2 in our research of historical ciphers. And in the last and shortest part, I will show you future plans with CrypTool 2. What is CrypTool 2? CrypTool 2 implements a so-called graphical programming language, as you can see here on the right side. You can put components onto a workspace, like a text input component, a Caesar component, and a text output component. You can connect these components, and then the text entered in the text input is encrypted or decrypted using the Caesar component, and the results, a plain or ciphertext, is shown in the text output. Right now, we have 199 components for cryptography and cryptanalysis in CrypTool 2. 3 years ago, we had another CrypTool Symposium, and at that time, we only had 170. So we have 29 new components in the last 3 years. Then we have 270 so-called templates. 3 years ago, we had 220. And a template is a pre-built workspace like this one, showing a cryptographic or cryptanalytic graphical program. We implement in CrypTool 2 classical and modern cryptography. Examples are the Caesar cipher, the substitution cipher, transposition, ADF-GVX, Enigma, M209, and many more. We also implement modern cryptography like AES, RC2, RC4, DES, Diffie-Hellman, RSA, SHA-1, Ketchuk, and many more. Also, we have cryptanalysis of classical and modern ciphers and cryptographic protocols in CrypTool 2. Examples are the Vigenère analyzer or our key searcher, which allows brute force attacks on symmetric modern ciphers, factorization, the Enigma analyzer, and many more. CT2 is now in the current version 2.1, and we released the last stable release in December 2022. And we support different types of builds. We have regularly nightly builds that are set up programs or builds of CrypTool 2 that are created every night, or when we have new source code added to the repository. And then, of course, we have stable releases. These are releases intended for usage in the classroom, for instance, or at home. And we have mostly stable programs or components in CrypTool 2. These are released 1 or 2 times a year. Then we have 2 installation types. You can either install via executable, via setup, we have an NSys installer, or you can download a zip installation. You can unpack CrypTool 2 and then just use it without the need of installing it. For both, we support automatic updates. That means that you either download automatically in CrypTool 2 a new setup program that is then run in the background, or the zip installation also automatically updates itself. We right now support 2 languages, English and German. And For that, we translated the main application, components, help, templates, the wizard, and many more. Currently, we use net version 4.7.2. We plan to update this in the near future. And we use right now Visual Studio 2022 Community Edition for CrypTool 2 development. Recently, already a few years ago, maybe 2 or 1.5, I don't remember exactly, we moved CrypTool 2 to GitHub. You can find the source code on GitHub with this URL. And of course, and you're watching it right now, we have an English YouTube channel, Cryptography for Everybody, that I maintain, and we have currently more than 5,000 subscribers. CrypTool 2 has main components. And the first main component that you see when you start CrypTool 2 is the Start Center. Via the Start Center, you can reach the other main components, like the Workspace Manager, the Wizard, and other components that I will show you later. First, let's have a look at the Wizard. The Wizard is intended for beginners. That means you don't need to create your own graphical programs. You just click yourself through these lists here. For instance, you want encryption, decryption, then classical ciphers, Caesar, and so on. And in the end, you can just encrypt or decrypt using the Wizard, or you can also use the Wizard to create a new graphical program and then use the Workspace Manager to execute it. The Workspace Manager implements the graphical programming language. You can see here a text input component with some text, a Caesar component, and a text output component. These are connected using connection lines here, the inputs and outputs. And when you have entered here text and you press play, then the workspace is executed by the CrypTool 2 environment and you get your ciphertext. Of course, you can also copy the ciphertext back into this text input, change the Caesar component to decryption. You select this. Here you will then see some parameters. You can change here then to decryption, and then you will see the plain text here. We have also distributed computing implemented in CrypTool 2. That's called the Crypt Cloud, which allows distributed cryptanalysis in the cloud. It's basically a peer-to-peer network in the background. You can create your own user and password, then connect, and then join, for instance, a distributed attack on the DES cipher. Then we implemented during the last years the so-called CrypTool Store, and this allows to easily publish components. For instance, if you want to publish components and you need some support, then you can upload these to the CrypTool Store. You can write me an email. I will then enable your component in the store so that people can download it, and I can also have a look at that component. To do so, you need to upload the source code to the store, and the store internally automatically then compiles your component and offers it in the store to others. We mainly use this method here, the CrypTool Store, to support our students. For instance, if a student wants some feedback on a component he or she develops in her bachelor or master thesis, for example, they can upload this to the store and then we can test it. And we can publish components, for instance, only in the nightly build or in the release version. Then, of course, CrypTool 2 has the online help. The online help contains information about each component in English and in German. It's HTML based. You can see here the list of all components, and you can just click, for instance, on ADFGVX, and you will get some information about the cipher and the component. We have an online help page for each component implemented in CrypTool 2 in our online help. Finally, and this is brand new, we implemented the so-called Crypt Console. And the Crypt Console allows the execution of CT2 workspaces in the Windows console. Why did we implement this? For instance, you want to create your own ciphers, or your own ciphertext, for instance, for research, and you need to create many ciphertexts. You can write a small program that extracts text, and then you can use CrypTool 2 to encrypt and decrypt text. As you can see here, you can just call the crypt console.exe with a parameter CVM file. This is a path to your file. Then you can define inputs that these are components in the workspace. For instance, we have here type, name, and data. And here's an example where we encrypt using the Caesar cipher. So our input is text. The name of the component we want to change is plain text. That is the name of the crypto2 component in the workspace. And here is the text, hello world. You could also define an input file, and then you can define the output. The output is a ciphertext component. And then you can see that after executing the crypto2 workspace in the crypt console, the ciphertext here is the Caesar encrypted text, hello world. And I just see that this here is not Caesar. This is a type X component that we used here, not the Caesar cipher. Now let's have a look at new highlights of the last 3 years in CrypTool 2. The first new highlight is a Hagelin machine component. And this component was written by my colleague Vasily. And this component allows to encrypt and decrypt using all mechanical Hagelin cipher machines like the M209, the CX52 and so on. And you also have a nice visualization here. And you can define, of course, all the settings of the cipher machine. Then I implemented the Ghost Magma cipher. I also created a video about that you can watch on this channel here. Ghost Magma is the Russian data encryption standard. It's a very old cipher, very outdated, but still very interesting. It's a symmetric block cipher. Then, also for a video, I created the Mexican Army cipher disk component. This device was used by the Mexican Army of the beginning of the 20th century. At the beginning of the 20th century. And you can see this device here. You have 4 disks that you can rotate. I also made a video about this, and this component allows us to encrypt and decrypt using that component. Also, I implemented the cryptanalysis of the Mexican Army cipher disk. In fact, the key space is so small, it's only a few million, that we can just search through the complete key space using brute force. This is a Mexican Army cipher disk analyzer. And as you can see, here's the ciphertext, and it found the corresponding key in about 5 seconds. So it's not a very strong cipher anymore. Or it wasn't even a strong cipher in that time it has been used. Here we have the Feel cipher. This is also a modern cipher, and I added this to the list of new highlights because I really like these visualizations of modern ciphers. These drawings look like the publications or like the drawings in the paper, and I try to add, every time I add a new cipher to CrypTool 2, also the internal drawings or the internal workings of the cipher as a presentation to CrypTool 2. And you can see here the intermediate keys and ciphertext, plaintext, and so on. Then we did a complete rework of the Enigma cryptanalysis, the so-called Enigma analyzer. Previously, we had no Enigma analyzer. The Enigma component itself implemented the cryptanalysis. We extracted we removed the old analysis code from the Enigma component, and we created a brand new Enigma analyzer based on source code from George Leslie. And it implements the bomb, the IOC search, hill climbing, simulated annealing, the attack by Gilligly, and many more attacks on the Enigma machine. Then we created the blockchain simulation. And we already also had a video about this. I think we had videos about nearly all of the things that I show you here in that video as highlights. And the blockchain simulation allows to simulate a blockchain. You can mine, you can simulate addresses, transactions, and so on. And here you can see a blockchain component. This computes the first block and its transactions, the second block, the third block, and so on. So you can add as many blocks or blockchain components as you like to this blockchain. You could also create a loop, so then you will have an endless blockchain in a loop. This is also possible. And this really nicely shows you how blockchain works. Then another highlight is the visual cryptography that I have implemented in CrypTool 2. With visual cryptography, you can encrypt a text using two images. You have a randomly generated image 1, and you have then, when you encrypt a text, a new image, and clearly before you communicate, you give the first image to the receiver, and then when you want to send the secret message to the receiver, you create the second ciphertext image here, and when the receiver then overlays these two images, he or she can read the ciphertext. And this is called visual cryptography. I also like this really much, and that's why I implemented it in CrypTool 2. Then a student implemented or re-implemented the steganography components really nicely. Here we have the least significant bit image steganography component, so you can hide text in an image and you can define which bits of each color channel you want to use for hiding the secret text. And we also implemented, or the student implemented, a second version of steganography in CrypTool 2, or image steganography. That is a bit plane complexity segmentation, or BPCS image steganography. Here, this is a more or less smarter algorithm that uses different bit planes based on entropy to hide the text. And in fact, it hides the text better, and it can hide more text than the previous shown image steganography, the LSB steganography. And here we have text steganography, also implemented by the same student. Here you can enter a text. Here you can see where your secret message is hidden, and then you get your final text. And as you can see here are some letters with dots, for instance, but we have different modes like dots or other markings of letters. Then, recently, I implemented the syllabary cipher. It's a cipher that works on letters and syllables. And as you can see this table here, you have syllables, you have letters, you have digits. And when you encrypt a text here, then you get these digits as a ciphertext, and the digits are defined by row and column. Also a really interesting cipher. Then another student implemented the Cha-Cha cipher, a modern stream cipher by Daniel J. Bernstein. And the really nice thing with this component here is the internal visualization, because you can step through the cipher in a very fine-grained manner. So when you step through the cipher, you can literally see data flowing through the cipher. Like here, this purple marked lines actually right now contain data, and you can just click here and forward and revert every step of the cipher. Really nicely made by the student. Then, a few years ago, another student implemented differential cryptanalysis, and he also implemented visualization of differential cryptanalysis with toy ciphers. With differential cryptanalysis, you can break a cipher with a chosen plaintext attack. This is really interesting and very powerful modern attack. Modern ciphers, modern new ciphers, all has to withstand these attacks. And I think I will make a video about the differential cryptanalysis in one of my future videos. Then we have the rapport component, also by another student. Rapport is randomized, aggregable, privacy-preserving ordinal response. This is a protocol or method developed by Google, and with this component you can learn how this method works, and you can test different parts of the method yourself. Then another component I recently worked on is the homophonic substitution analyzer. This allows the analysis of homophonic substitution ciphers. You probably also have seen this in a few of my videos. Recently I added to this component the possibility to find log nomenclature elements. When you have a homophonic cipher, then you can, or the people extended these ciphers using nomenclature elements. These are, you can say, code words or symbols that represent names and places and so on. And these are very rarely used in cipher, and you can literally not decrypt these. And since these disturb or make problems when you want to analyze a homophonic substitution cipher, you can just click now on Find Log Nomenclature Elements, and it will automatically mark elements which it thinks are nomenclature elements. Another very nice component we have, or not a component, a workspace we implemented. This is Gematria. Gematria is actually not cryptography. It's an esoteric thing, you could say. With Gematria you compute the sum of words. For instance, here we have Josephus Imperator regnat amore et timore, and the workspace here computes a sum over these words, and the sum then stands for some properties of these words. Of course, this is bogus, but I just wanted to test if we can create these in CrypTool 2. I also made a video about Gematria because I found a paper in one of my old books about Gematria. If you're interested in that, I suggest that you have a look at the Gematria video on this channel. Then another really nice workspace, a really large workspace, is our number station simulation. With the number station simulation, you can enter digits in CrypTool 2, then press play, and then these digits will be played back using audio, actually using my voice. And number stations were used and probably are used also right now by secret services to contact their agents in different countries via radio. And here is a list of other new or re-implemented components that I didn't want to make additional screenshots of or add these to this talk, like TypeX, Cipher Machine, Nihilist, Bifid, and so on. You can see this large list, and probably I also missed a few components when I compiled this list. Now let's have a look at how we use CrypTool 2 in our research. Research with CrypTool 2. The first example I want to show you where I actually use CrypTool 2 for my research are the Maximilian II ciphers. These are 5 ciphertexts from the 16th century that were sent from or to German Emperor Maximilian II. They were from 1574 and 1575. I think I will make a video especially about these also in one of my future videos. Here you can see an example of such an encrypted letter from or to Maximilian II. These are in the Haus-, Hof- and Staatsarchiv. That is an archive in Austria. I use the homophonic substitution cipher with nomenclature. This is a homophonic substitution cipher with nomenclature elements. And we solved it, my colleague Michel Waldesbühl and I, with the homophonic substitution analyzer that you can see here in CrypTool 2. I've previously shown you the homophonic substitution analyzer on a previous slide. Then the second cipher that we solved or deciphered using CrypTool 2 was the Ramanacol cipher, which is a Dutch ciphertext from the 17th century. Actually, I cannot read or speak Dutch, but the nice thing with this cipher was that the key was also included in the archive. The cipher is, as I said, a Dutch ciphertext from the Dutch East India Company, VOC. The dating is 1674. It's a homophonic cipher, but was used incorrectly. So you had homophones, so more than one symbol for a letter, but the one who used the cipher only used one per letter. So that was very weak. And as I said, the key is known, and we were able to enter the key, to enter the cipher, and decrypt it using the substitution component of CrypTool 2. And the final and last cipher I'm currently working on is a partially encrypted letter to Axel Oxenstierna from the 30 Years' War. This is work in progress. It's a partially encrypted letter from Sigismund Heusner von Wandersleben to Imperial Chancellor Axel Oxenstierna. It's from 1637. It's a homophonic substitution cipher with nomenclature elements, and we already solved it using the homophonic substitution analyzer. Our main problem is a really difficult German and some or a lot of nomenclature elements that we still need to identify. Also very interesting, and CrypTool 2 is really helpful in solving it. Here you have a few publications that in which we used CrypTool 2, for instance, deciphering 3 diplomatic letters sent by Maximilian II in 1575. This is in Cryptologia, or 2 encrypted diplomatic letters sent by Jan Koktkiewicz to Emperor Maximilian II in 1575 and 1574 and 1575. This was published on the Histocrypt, and many more publications related to CrypTool 2. Now let's have a look at future plans with CrypTool 2. Our basic ideas are that we want to make CT2 even more attractive for users and developers, of course. That's always our goal. We want to advertise CT2 more, for instance, with YouTube, Facebook, and so on. So if you want to help us, please like, share, and subscribe, and so on, to make CrypTool 2 and the YouTube channel here more popular. We want to establish CT2 even more in research and teaching that we are currently working on. We want to also motivate companies and agencies to use and extend CrypTool 2. And we want to continue implementing current developments of cryptology, especially classic and historic cipher analysis. There we work in the Decrypt project, and of course modern cryptology and cryptanalysis. For instance, we want to create a cipher building kit for CrypTool 2. And of course now we want to know, what do you want us to implement in CrypTool 2? Do you have any wishes, or what do you think? What do you want? Please write this below this video, and then we can have a look and decide if we might implement this in CrypTool 2. Yeah, and this is all I wanted to show you in my talk. I have shown you many highlights of CrypTool 2. I've shown you 3 examples where you use CrypTool 2 in our research, and I've shown you our future plans with CrypTool 2. So if you like this video, please give a thumbs up. And if you did not yet subscribe to this channel, please also do so. This really helps us to grow the channel and to make CrypTool 2 more popular. So thank you very much for watching, and see you in the next video.